Right, well, it's our pleasure to welcome James Patterson, M1DST, who's very kindly come along with these very interesting bits to talk to us about 3D printing for the radio amateur. So without any further ado, I'd like to hand over to James. Welcome, thank you very much.
Well, thanks for coming along today. It's nice to see a good turnout. I don't think I've met any of you before. Don't think so. Have I met anyone? No? Okay, good. That gives me a little chance to... Here we go. Give you 5 seconds about me. Someone asked me earlier on how long I've been licensed. I'm not sure. It's almost 20 years. I'm M1DST, and I've also got the short contest called M1N. Currently the chairman of the Swindon Radio Club. I've been in that role on and off for the last 5 or 6 years. I enjoy contesting. I write software most of the time during the day. I don't collect USL cards. I know enough CW to get me into trouble, and I like making things. Be that electronics, woodwork, basically any kind of construction is what interests me. It's the 4th time I've given the talk tonight. No, let's say it correctly. It's the 4th time I've given the talk. Tonight. The content changes periodically, so if we run long, then just someone give me a nod and we'll speed along. I'm also giving a much condensed version of the talk at the RSGB convention. Okay, so we're going to talk about a few things tonight. We're going to talk about different types of printers, the materials, the parts of an Fdm printer. Some of these things may mean something to you, or they may not. CAD, splicing, how you prepare to print, actually doing the printing, any kind of maintenance you might be, or you should be doing, and then other bits and pieces. So I know one 3D printer here. Anybody else 3D printing? Okay, you're 3D printer. So, anyone got any questions? These 3 people here are experts at 3D printing. Okay, so let's talk about printer types. It's not as easy as saying I've got a 3D printer, because it means different things to different people. So let's talk about the first type of 3D printing you can get. This is the most common. It's called FDM, or Fused Deposition Modelling. It's probably the most inexpensive way of starting with 3D printing. And as you can see here, we're laying a plastic filament down using something called a hot end and an extruder, and it lays on top of each other. The second type of printing is called SLA printing, and that is uses a horrible goopy mess in here, which is the main reason that I don't want to be involved with it. And it uses well, two different forms, but mainly like a DLP projector underneath here, similar to the size of your mobile phone in this case, and it's projecting UV light at this UV sensitive resin here, and then it basically produces the model that way, and then you have to cure it at the end of it, so it's a little bit more involved than your basic FDM printer. So the next type, I can't tell you too much about this because I'm not too sure how it works. It's a proprietary system produced by Carbon, and they are doing something with chemicals. It's very similar to the SLA printing that we just spoke about, but they're injecting oxygen in there, and there's some other chemical
yeah, the UV speeds up the curing, and the oxygen actually slows it down, so they can balance the two to get the layers on.
See, I told you there was an expert in here. And then you bake it at the end, and then depending on how you bake it, depends on how the material changes in some way. And then the form more industrial is SLS, which is a sintering process where you get a layer of powder here, and you're exposing it using a laser, or sintering it with a laser, and then an arm comes over, the bed lowers down, and then the process carries on.
The nice thing with that is you don't need support material.
Exactly, yeah. So, I'm not sure how well you can see some of that. Is it okay? Can you read some of that? So these are, in brief, the different types and some of the benefits of each of those printing methods. If anyone wants to see that in more detail, I can show you that afterwards. So the types of materials that you would use with a printer, probably the most popular nowadays is PLA, which I think comes from potato starch or something like that, is where it came from. ABS, some of these things I'm sure you'll be familiar with, nylons, various flexible type thermoplastics. Hybrids are quite fun. I think I was given a sample hybrid here. So this, you can either infuse it with wood fillings or metal fillings to make it magnetic, or also what they can do is produce two different types of plastic that give you the best of both worlds between PLA and ABS. So maybe it's easy to print, but it's more durable. And then you also have infused filaments as well. So why have I put a coffee cup on there? Well, an infused filament could be infused with a smell. So there is a filament that you can buy that when you're printing smells like coffee. Why you would want to do that, I don't know, but you can.
Bacon as well.
It was bacon as well. That's right. Okay.
Now you're talking.
Why you would want to do that, I have no idea, but you can get them. Okay, so here's one that you definitely won't be able to see, so let's zoom into that. So these are the different types of materials that you can get, and we're talking on here some of the various bits and pieces. So the first row on there is strength. You can see the blue one along the top here, and then we've got stiffness and durability and then maximum temperatures and things like that. So you would select the type of material that you print with based on the type of result that you want at the other end. Do you want a strong part? Do you want something that's we've got resistance to UV? Do you want it to be able to flex? Maybe you're creating a rubber wheel or something like that.
Some of them are quite brittle as well, even between PLAs. Some of the PLAs are more brittle than others and things as well.
And then we've got the bottom of the sheet here, which is showing us, again, things like UV resistance. It's difficult to see on my tiny screen. So you've got UV resistance and things like that. So there's a nice little chart there to help you work out the best type of material for the type of thing that you want to get out the other end. So what kind of things could you print if you had a printer? Well, so here's some of the kind of things that I've produced just over the last year that I've had a printer or so. I had an analyzer, and it's one of the old-fashioned ones with a button on here, and every time you put it in the box it turns itself on, and every time you want to use it it's got a flat battery. Pointless. They then revved it and they put a special button guard around the outside, and the problem with that is now you can't get your finger in to actually turn it on. So I just mocked up a couple of different test pieces for a bottom guard, and it's big enough for me to get my thumb in there and push the button, and I just double-sided taped it to the front, and now I haven't got a flat analyzer. My K3 is in one of these pelly case type things. One of the big problems with these pelly cases is it's great getting your rig in there, but if you want any accessories and things like that, you've got to have a hole cut in the pull-out squares. The problem with that is over time it ages. So I just printed a relatively large box, and it is quite a large, deep box that I can put some accessories in.
How long did that take to print?
Don't remember, to be honest, because a lot of the time once I see it going I'll just leave it running, and it just runs overnight, and then I look at the results in the morning. So this is actually a two-part print. There's a break in the middle here, but pushed together and taped on the outside, you can't see it. But you can do other kinds of prints. So here's my V&A. Again, it's in a nice case. Not sure what you can see on here, but I printed a kind of an elbow-shaped, an L-shaped insert on here, just to keep all the adapters and cables and bits and pieces together, because again it stops all of this protective stuff from coming out. So all of the things that I've been printing over time, 99% of them have been function. I started 3D printing as a tool, really, to add things. Last year I started working on a remote knob. So I started this. This is similar to the K-pod that you get for the K3. but cost a fraction of the money, and the original project started before the K-Pod became in existence. And when I got a 3D printer, I was then able to refine it a little bit more. So I caddied up the bits and pieces and printed them out, including the knob. So rather than buying a knob, in fact the one I actually use at home has got a genuine Elecraft knob on it, but as a test I caddied up a knob just to see how it would behave, and it came out quite well. So there was also a project I found online, which is for a case for holding my peak LCR meter. So that's quite nice. Another thing I found online, those yellow brackets over there, and this just holds my Rigol scope and keeps all the leads in order. So yeah, rather than printing silly little chess pieces like that thing out over there that I printed as a trophy for my daughter for a chess competition, I think that's probably one of the few little bits of rubbish that I've printed. Everything else has been relatively functional. And then I think these are a few little sample quick prints I did just to go on the top of a fishing line, so you could use it for attaching very thin wires to create a dipole topper, rather than waiting a day for them to be shipped or whatever. You could print it yourself.
What density of those prints?
We'll come to that a little bit later, but it can be anything from completely hollow to completely solid, and you choose that. So here's something I saw on Twitter the other day. Does anyone know, you recognise that handle? Call sign even. What he's done here is he's created an SMA spanner and 3D printed it in metal, which is quite nice. And he's also in the last couple of weeks been producing a former for an antenna and then sticking tape on the outside. So that's quite nice because it's reliable. You can get the same thing over and over again. And printers come in various forms. They start very small, like this one here, which would be a tiny little desktop thing like that, right up to something that would fit into a factory, and that's a full-size Fdm printer in that case. Or you can get very, very large. This is just a mock-up of something which exists in France. They're starting to 3D print houses, which is incredible. They design it and they print them, and then they fill it all up with some kind of filler to insulate it. But they can build houses extremely quickly without brickies.
They even 3D print the window holes and just shove the windows in.
It's very, very, very good. So if you go onto YouTube and search for 3D printed house, you'll find loads of videos on there of 3D printed houses. So let's talk about Fdm printers, because they're probably the easiest to get into. They're the most inexpensive and they're not particularly messy. Two types of printer. We've got the Delta printer here and the Cartesian printer here. So the Delta printer, if we look at how that one moves, what you'll see here is it's got a couple of arms all connected to a single point, and they move up and down, and using some trigonometry it's able to work out the angles to be able to move that point there to any point along that round bed. The benefits of that particular type of printer is you can print very tall prints. The downsides of it is generally the bed is very small at the bottom, so you can't, it's round at the bottom, so you can't have very large squarer shaped pieces, and also in terms of the places you can reach with this aren't ideal. So most people are buying Cartesian type printers, which is moving this hot end around in an XYZ plane, and they look like this. So we've got a y-axis, which is typically the bed moving backwards and forwards. We've got an x-axis, which is typically the hot end gantry moving left and right, and then we've got the z-axis, which is moving the whole thing up and down. And that's typically what it would do. And you can see on here we've got stepper motors and bits and pieces on here. So let's try and point out some of the bits, so that when we talk about them you'll know what they look like. So the hot end is typically this little piece here under this is a little a little rubber condom on here to stop you getting burnt. But a hot end would typically look like this, just a block of metal with a heating element inside it, oops, and a thermistor inside there to heat it up. We then have a heat break, because whilst you're heating up plastic, what you don't want the heat to do is to rise all the way up to the top and start melting your filament before you are ready to actually push it through. We've got some linear rails, which is any of these rails across to smooth bars effectively, a couple of fans to keep things cool, a bed which moves, some stepper motors which are very accurate motors for moving everything around, some screws, leaf screws to move the gantry up and down, belts to move things around as well. The extruder is hidden away up here on this particular one. There's some bearings as well, and then the nozzle. So let's talk about some of these. So this is a typical nozzle. It's a brass nozzle. It's very, very small. There's an example of a brass nozzle. You can see how small that is. They're replaceable, so it's a consumable part. They come in lots of different sizes. Typically 0.4 is the size of the nozzle you would get if you were to buy a 3D printer. And that's a good balance between speed and accuracy of the print, but fidelity of the print. So here's our hot end, as I was showing you, with the nozzle on the top and the heating element that goes in there, and there's a little thermistor in there to feed back to the printer. Here's an example of a heat break that would screw into the heating element. So the idea about that is it's a big heat sink, so when your filament is running through here like that, you only want hot filament here, you don't want it back here. So that keeps that nice and cool. This is what an extruder looks like. So this is the part that takes filament, and we'll talk about that in a minute, and takes it off of a roll, and then basically uses these geared teeth here and an idler and pushes them through here into the heating element and then down and out through the nozzle. So we've got belts. I'm sure you all know what belts look like, and stepper motors. And then we've also got the filament that we were talking about. So this is how you would typically get filament. It would come on a roll. You can get it in lots of different colours. There's all kinds of examples of filament. If you weren't sure what it looked like, pass those around if you like. It looks a bit like strimmer wire. You can get it in two different sizes. Well, I think 1.75 is probably the most popular nowadays. I think 3mm was very popular in the early days. And they come in various different sizes of spool. Oh, you dropped it. So you've got your blue filament coming through, but that's not particularly interesting. What's more interesting now is the ability to have multi-materials. So what do we mean by that? Well, if you've got a black filament and you're printing something and printing something out, you get a black piece out the other end. You know, something like that. Wouldn't it be nice to be able to print something that's full of colour, or at least maybe two colours? Well, that's where we are approaching nowadays. Here's an example of an aftermarket splicing unit, which not only drives your printer, but you can run 4 individual filaments into it, and it calculates exactly how much filament it needs at any one point for almost just-in-time delivery, and then splices the filaments together and actually mixes it in real time, which is quite nice. And then this particular one up here, most of it you can't see because it's all the good stuff is behind it. I think this one's capable of mixing 5 different filaments together. So maybe for me, multiple colours isn't particularly useful, because you can see most of mine are functional pieces rather than anything else. That you can do more than the biggest pain is changing the filament. So one day you might be printing black, and then you might want to print white. So you've got to clean everything out. If you've just got 2 colours being fed in, you can just immediately select which colour you want, and there's no messing around. There's another thing you can do is you can feed in a different type of material, maybe a flexible material or some kind of PVA based filament, which allows you to create supports. I'll explain what that is in a minute, but all in a single print. So it just makes the actual printing process far simpler. I think Norman, wasn't it? Norman was showing me a print earlier on that he had done with multiple colours, but he did it manually. He did it manually, didn't use any of these devices here. And that works perfectly well when you're printing something flat and quite thin. As soon as you want to start doing anything else that's remotely more than a few layers deep, you need some kind of multi-material machine. What does it allow you to do? It allows you to print fun things like that if you want. All in a single print, so it's a bit more interesting than just having a yellow penguin or a black penguin. So what's the process? What's involved? Well, typically you would start with CAD. Here's a few examples of some CAD tools: Fusion 360, Tinkercad, Onshape. Just pretend you're not seeing that yet. They're all free CAD tools that you can use as hobbyists. You can just download them from the internet. I think Onshape is based online in a web browser, and you can, so it's Tinkercad actually, and you can use them. I wasn't going to mention OpenSCAD, but that's your favourite. That's your favourite CAD tool. If you're into writing code essentially to create your 3D shape, then OpenSCAD is your tool. I like to see things and move things around, so traditional CAD is what I'm into. And then there's the other option is you don't do any of that and you just use Thingiverse. We'll talk about that in a minute. But your ultimate goal through this whole process is to get something called an STL file out the other end. An STL file is basically a file which contains all the information about your 3D model that you're going to print. So, what should you be considering when you're doing CAD? Well, the first thing is parametric design. What do we mean by that? Well, the OpenSCAD guys all know what that is, but let's use this as an example. The manufacturer that designed that box also produces other boxes very similar to that, all in lots of different sizes. But there are lots of things that stay consistent with that box, regardless of whether it's this size, or this size. And that might be the thickness of the wall. That might be the distance or the size of the mounting holes, or the distance those mounting holes are from the corner. So what you can do with parametric design is CAD up your model just like that. But rather than saying the width or the width of this particular box is 100 millimeters, you can turn this into a parameter. Which means if you want to print a box this big today, you can just print it. If you want a box that's 20 by 20, well, you change the 100 to 200, and then boom, your box just scales. And all of the other things that you've got static won't change. So it means you're able to iterate on your designs without having to start from scratch every single time. What else have we got? If you're using different materials in your CAD, a good thing to do is to highlight them with different colours, because it's clear then that maybe it's a separate piece. Don't always try to do things in one piece, because the problem with 3D printing, FDM style, is you're printing layers on top of each other, and there is an inherent weakness in that, because you just snap it. Because you've effectively just sat plastic on plastic on plastic on plastic, and there's a weakness in here. So sometimes, if you could print things in more than one piece, so another example would be this particular mount. It's an interesting shape, but it was actually two separate pieces that were CAD'ed, printed separately in a nice way, and then just screwed together. It's always best to try and avoid printing in a single piece if there's strength involved. Is 3D printing actually the solution for you? Because it's not the solution every single time. Sometimes using a CNC machine is better. Sometimes just knocking something up with a bit of wood is a bit better. It's not always the solution, even though all of these boxes that I've 3D printed, I could have used a bit of cardboard or something and done the same thing. But again, I can CAD these up fairly quickly, hit print and walk away, and all the magic happens. And the final thing is, am I reinventing the wheel? A lot of times we'd like to reinvent the wheel as hams, either to prove that we could do it, or I don't know, it just seems to be in our nature. So the first thing to do is to check Thingiverse. So let's see what Thingiverse is. It's a website that contains all kinds of interesting 3D designs and models that people have already done for you. And there are tens of thousands of 3D objects already on there that you can just download for free and print. And people review them, you can see whether they worked, whether there's an inherent design issue with them. Maybe you want to download them and then...
That's where that came from.
Okay, there you go.
I think that came from Thingiverse.
And then tweak them. So the example here is this is a loading coil. Obviously you need to wrap your wire around it, but it gives you, it's a former for your loading coil. There's a what have we got here? A 3D printed CW key and various other bits and pieces in there. There's just tons and tons of stuff. That chess piece came from Thingiverse. Anything that you can imagine has probably already been designed by somebody else several times and on Thingiverse. So once you've got your 3D model, you need to do something that's called slicing. And what does that mean? Well, you need to run it through another piece of software that basically tells the 3D printer how to print the model. And because there's lots of different styles of 3D printer, you need to configure the slicer. So here's a couple of examples of slicing tools. There's Simplify 3D, which is the one that I use, but it's a paid tool. There's Cura, Slicer, and Slicer Prusa Edition. Now, as of tonight, I would recommend anybody else starting to look at this, maybe to actually look at Slicer Prusa Edition, because as of tonight, the only benefit that we had from Simplify 3D has now been built into Slicer PE. And I think that dropped about 6 o'clock this evening. And all of these are free, all of these 3 tools. This one is about 100 quid, I think, for that particular one. So, we got supports and various other bits to talk about, so let's talk about supports. So, let's pretend we wanted to print this particular 3D model. It's a man or a woman, got their arm out like that. And what you've got to think about in your head is, if a 3D printer is going to print that, where's it going to start? Well, it's going to start at the base, and that's all fine. Keep moving its way up, producing all of this, and then it will start squirting filament out to do the arm. Oh, well, the filament will just drop because there's nothing for it to support on. So what these slicer tools allow you to do is to add supports. And this is basically waste material that gets printed alongside, and the slicing tool calculates all this, so you don't have to build this into your 3D design. And it understands the capabilities of your printer and basically calculates the minimum level of supports that you need to be able to successfully print your model. So in this case, if I was to print this, all of this would be waste material, but it would be very thin, just enough to be able to support the weight of that arm. And once the model had finished, I could just break that away and it would be relatively clean, and I would have my 3D model. So we have rafts. That is typically, you would use a raft if you had something maybe with you wanted to stick extremely well to the base. Now the biggest reason you want them to stick is if you imagine you're printing. Let's turn it around, which is the least offensive one. Let's try that one. Okay, so you're printing to your bed. The last thing you want is, as the part starts to cool down, because what you've got to imagine is you're printing hot material all the way around, and then gradually over time that plastic is starting to cool, yet you're putting more hot plastic on the top. So what it's going to want to do is to start to warp and twist and pull itself off of the bed. And I think I brought this one as an example of one that started to lift at one point. And if I pass that round, it's just a scrap one, but you'll see that it didn't actually print square at all because the corner started to lift off, and we ended up with an odd shaped part. So in this particular case, this wouldn't have solved that. But if you've got a small part that might be small and tall, there are various things that you can do to help the part stick to the bed so it doesn't fall over or come loose. Because if you've ever had spaghetti, then a bowl of spaghetti, that's what you'd get at the end of it if your part breaks loose. And I've had that happen, I think, once or twice, and you end up with a real mess and plastic.
People refer to it as a bird's nest.
Okay. So this is a skirt, which is basically I leave this enabled on all of my prints. The first thing the printer does before it prints any model is it where's my pointer gone? There it is. It does a couple of spins around the model. So number one, you know exactly where it's going to print on the bed. It should be where you thought it was. But number two, it primes the nozzle. It makes sure that plastic is running out of the nozzle before you start working on your main piece. But what you can do is you can upgrade that skirt to a brim, which is exactly the same. The only difference is it keeps going all the way and does actually touch the model. The benefit of that is it gives you much more surface area sticking to the bed, so you've got less chance of your model falling over.
It helps with warping as well sometimes.
Okay, so you were asking about infill.
Yep.
So here's some examples of infill. Not sure how much you can see on there. We've got various, so we've got 0 at the bottom here, 5, 10, 20, 25. So various types of infill. So if you were printing something, let's go with this. This is a Queen. There's no point in me just printing solid plastic in that. It's not going to give me any benefit whatsoever. So what I want to do is to print the minimal amount of plastic inside here as I can get away with. So you would
saves you time as well.
It saves you time, saves you money, and the other thing that you can do with it that I didn't talk about earlier on is if you've got multiple filaments coming through. So maybe I'm printing yellow and black. Every time you change filament, you need to purge away some of the other filament you had. So if you're just printing yellow and now you're going to suddenly start printing black, you don't want to mix bits of yellow in where it should be perfectly black. So typically you would have something called a purge block, which the printer moves to the side of the bed to an unused part and just basically squirts out the filament until it gets a solid black, and then it will come back. One of the new things that's starting to happen now is purge, because it's a complete waste of plastic, is the infill is actually being used as the purge, because you don't care what colour it is inside. So if you could have all kinds of interesting colours in here just to get your colours nice and clean. And you get various different styles of infill, and you would pick them based on whether it was there's some kind of artistic thing that you want to do or strength. And the biggest thing, do we have any machinists in here? Couple, so speeds and feeds mean something to you? Okay. Well, same as the case for 3D printing. You can't 3D print at light speed. There is an inherent link between the amount of heat you can get in that heat block, the amount of filament you can push through the nozzle, all those kind of things. So there is a balance, and you have to work out really a good temperature per filament, and also your machine to how fast you can actually print, and you would dial that in over time.
If you're printing a structure like that box, for instance,
Yes.
and you have the misfortune either to the feed jams or you run out,
Yes.
When you start again, is there an inherent weakness? Because the base, the lower bit might well have cooled, etc., etc. So it's a bit like a huge concrete pour. Ideally, you do it in one go.
I guess, yeah, ideally it's one go, but there are fans cooling the plastic down as you're going on purpose, because what you've got to imagine is if you're melting it, you don't want it liquid, you want it liquid just long enough to be able to lay it down and then stick. There probably is a weakness in there, but a lot of these modern printers now, have actually got the facility in them that if you run out of filament halfway through a print, they're intelligent enough to understand that you've run out of filament, to stop, allow you to change the filament and then carry on again. Or also maybe you get a power cut, and if you're doing a print which could be a 20-hour print and you get a power cut, you want to be able to carry on at the end of it. So I think I'd prefer to carry on rather than start again with my print. And then basically at the end of this, at the end of the slicing system, you get something called G-code. And G-code is used for 3D printing, for CNCing, and it's basically, say, machine readable set of commands. They're just text. You don't typically get comments in them. That's just here for your benefit. And that would just tell the printer each command what it's expected to do. Heat the nozzle, go home, start extruding, move at this speed, move from this point to this point. So that is G-code. So we've got our G-code, we're ready to go. What will we need to do next? Well, the most important thing is to level the bed. If you don't level the bed, the printer will assume it's already level, and your print will be uneven, might not stick properly. Is another thing. The printer won't actually know where it is. It's thinking that it knows where it is in space, but if you're moving your head and your bed is moving, the worst possible thing is for the head to actually crash into the bed. Next thing is to clean it, keep it clean. I typically clean my bed after every single print. Home your printer so it knows where it is, and start heating the bed if you're using if you've got a heated bed. So the next thing is you want your filament to stick to the bed because you don't want it moving around. You've already got a hot end moving around. So there's several ways of sticking your part to the bed, and that's the good old-fashioned glue stick like you used to use at school, and you just run the glue stick over a piece of glass, which you could be using, wait for it to dry, and then print on top of that. Another way is the good old PVA glue. Mix a bit of water up with it, paint that onto the bed, let that dry. Another thing people are using is hairspray. Guess why? Because it's got PVA in it. So let that dry. Various different types of tape, painter's tape, Kapton tape. Is that any tape? I think it's only those two, isn't it?
Masking tape as well.
Yeah, kind of like painter's tape and Kapton tape. But okay. The other thing is ABS slurry. It sounds horrible. It is horrible. You get some ABS spare filament and you mix it with acetone and it creates a horrible goopy mess, and you paint that onto your bed and that really does stick. I ruined a bed by using that, so lesson learned.
The painter's tape is very, very good, but sometimes it's a pain to get the part off the tape afterwards.
So what I use is a PEI bed. I'm not going to try and pronounce it, but it's basically a thin layer of plastic. It's that I've stuck to the aluminium bed. And I think the way that works is when it heats up, it kind of opens its pores up like your skin. You print on top of it, and as it starts to cool, all of the pores close up, and it releases the part off of the bed. So it's much easier to get the part released using something like that. And also, all you have to do is get some IPA and just clean it over, and away you go. I guess you're changing your tape every couple of prints, I guess,
Not
at the moment. No, I guess it depends if you dig it out with a.
I tend not to dig it out.
Okay.
The other thing some people have are these flexible ones, so you can get a magnetic bed.
Yes.
So it's flexible, so you literally just peel it off and seal the parcel with it.
Yeah, it's like a spring steel type bed, and in fact the newer ones are spring steel bed with a PEI powder coating on them, which is kind of best of both worlds in there. The types of tools you might use are blades, don't cut yourself, and scrapers, again, don't cut yourself. We'll come back to that later. But they're kind of the tools that you need once you've got your part stuck on the bed and you need to get it off. Because you don't want to break the part as you're taking it off the bed because you stuck it down with glue. We won't do the boiling water demo because we haven't got any. What I was basically going to do is I was going to just get a part, dunk it in boiling water just to show you actually how flexible some of these parts are.
So if you have boiling water if you want it.
Yeah, we can do that.
Yeah, all right. Let's do something like that then, because you're printing typically at around 200 degrees, something like that. Yet some of these materials are still fairly flexible, even at boiling point. So the reason I brought this particular part along is because this was left in my conservatory in a box in direct sunlight, and my conservatory reached, I can't remember, it was over the summer, extremely hot temperatures, and this buckled and bent and went all horrible. All these demo pieces over here bowed, so this was no longer flat, this was kind of bowed because it was all in the box. And it was particularly annoying to find that 3 days ago before I was coming to show you some of these things. So what I actually did is laid it on a baking tray and put it in the oven, and it just heated it up enough just to be able to straighten itself back out again. So let's show you how flexible a piece can be. Let's find something that we can break easily.
You can get a huge bottle of PVAs in the panel there.
What have we got that we can break? Well, maybe just use a piece of filament just to show you how easy it is to stretch some of this stuff.
You can have a tail hinge if you want it. Use that.
Okay, give that a try.
Strong bit.
Just put it in here. Shouldn't take too long. So you can already see that this is now much thinner. Give a bit more heat on that. So if you get something that doesn't quite fit, you can just tweak it, just in a bit of hot water. Oh, there you go. Look at that. And that will then, if I just hold that in place, as that cools, that should stay there. So where can you buy these things from? Well, pretty much anywhere, actually. There's so many people producing 3D printers now. It reminds me of the 80s when every man and his dog was producing some kind of computer. And they range in various prices, but let's have a look at some of those in a minute. You can even buy them from Aldi. Was that last year or the year before? I think at one point. These are now commodity items. Super cheap. They're rebadged, third parties. But most people are building on a design by this company, who is called Prusa Research, owned by a guy in the Czech Republic called Josef Prusa. And anytime you see a 3D printer with the i3 name on it, it's because this guy open sourced the design and the software and everything involved in it, and released it to the world, and now all of the Chinese people are mass producing these for a fraction of the cost.
You pick them up for about 80 quid, bit of rubbish.
Exactly. So this is the latest version that he has. It's called the i3 Mark III. It's got all of the bells and whistles under the sun that you can imagine. It's got filament sensors to know if it's run out of filament. It's got bed leveling, auto bed leveling. So one of the things that I hate doing is leveling my bed, i.e. you've got, for me, in each of the corners here, I've got little screws, and I use a piece of paper and I move the nozzle till it's level with the bed, and I just move a piece of paper and I manually turn the screws until there's just enough gap to be able to wiggle that piece of paper. You don't have to do it every print, but it certainly helps. It's a real pain in the backside when you want to print very quickly. So all the better printers have a little sensor on here, and they just go through a calibration process every single time. No more bed leveling. It's fantastic. There's all kinds of other things in there, like power outage detectors, and it writes to RAM. The last point, it was in the print, so when you power it back up, it says there was a power outage detected. Do you want to carry on? And you say yes. Heats everything back up, rehomes itself, works out exactly where it was, and carries on the print, and you haven't wasted 20 hours on your print. The bed comes off on this one. Spring steel, it's PEI coated, so you get all that kind of stuff. It's a nice steel frame, it's safe, and it's the printer that I recommend if someone just wants to get into 3D printing. It's not that expensive, but if you really don't want to, you could do what I did, but please don't. I paid less than 150 for mine. It came from China. You put it together yourself. It's all acrylic, which means if you're not careful it can bend and things can shake loose and things like that. So part of the maintenance is to clear it all up, but actually the prints aren't too bad out of it. It's good enough for what I want to do. And then a bit of breaking news is the Prusa guys have just released last weekend the Prusa SL1, shipping in a few months' time, and that is the first open, as far as I know, the first mass-produced open source SLA printer with the full support of the Prusa guys and all of their software. So that's quite exciting. Just a couple of things I printed that you can see over there. I've upgraded mine with a few LEDs and bits and pieces in there so you can see the status of the print. I've also mounted an external SD card reader onto the top of the device because, of course, there was no thought went into the design of how you're going to get your little SD card into the back of this printer that's on your desk that you can't reach around. So half the time you drop it and you lose the SD card. So I just put a little extension on there that I bought from eBay for 99p or whatever, and that plugs into the back once, and now I've got easy access to the device. I upgraded the power supply because they put a fairly woeful power supply in there.
The cheap ones have a habit of bursting in.
Yeah, they're not good power supplies at all. So yes, you can pay 150 quid, but then you've got to spend a load of money fixing things up and making things safe, and the better printers have got protection around the mains and all kinds of stuff. Mine's out the way, so not too much to worry about there. But when mine came, it was broken. Perfect. That's exactly what you want on a brand new printer. So I contacted Gearboxes, who said, no, we don't have any spare parts for it, but we'll send you $25 if you go away. So that was the end of that. So I super glued it back together and I used the $25, or was it $50? I can't remember, but I brought a whole reel of filament and got them to send me that as compensation, and it's been okay. If you buy
3D printer, you part for it.
it needs to be. It's a structural element, so you want it to be quite robust. But I'm sure there's someone probably producing spare parts for it. But I glued it and it seemed okay, and all was well. So there we go. So finishing tips. So you've got your model. You've maybe still got supports over the top of it. What do you need to do? Well, if they're just normal supports from the same material, you get your snips out, you cut them off or pull them off, break them off. If you're really posh, you've used PVA supports because you've got a multi-material printer. And what you could do is, so you had supports in here, you could just drop this into some water and just dissolve the PVA away, and then you get a perfect part out the
The
other
other thing
end.
you can do is what I've seen people do is have a knife in boiling water and just cut it with that, because that makes the plastic
That's
soft.
quite a nice idea. Yeah. Okay. Smoothing. So if you're printing in something like ABS, You can use acetone vapor, so tip a bit of acetone onto a paper towel, put it in a box, and the vapours that come off of that will actually smooth all the parts so the layer lines won't be so visible.
That only works with ABS then.
Yeah, exactly. Did I say that or not?
Maybe I'm misheard. Yeah,
Okay.
It won't work with PLA basically.
Yeah, exactly. So you have to use ABS. Otherwise, you've got to treat it like a car, sand it, prime it, paint it. There's an example here of something I just painted the other day just to see how it would come out and show you guys. So it started red, and I didn't bother to sand it or prime it or anything. I just got some matte black spray just to see what it was like. Pass that around. But typically I just print single colour prints, and I've got no interest in filling in the gaps or painting them. The main problem is gluing. It's fairly difficult to glue parts together without using all kinds of exotic glues. So super glues won't work particularly well. If you're using ABS, you can use acetone. You can paint acetone onto it, and that will melt the pieces enough that you can then bond them together. This is the one that I wanted to show you. So I printed that on the bed that way. That's all good. So what you've got to imagine is the layer lines are running this way, which means there is an inherent weakness if I was to try and break it apart this way, which is fine because the part is up here, so I'm not going to do that until you get to the legs at the bottom here. And what happened was I can't remember, I banged it or dropped it or something and actually just snapped that because there's no strength in here at all. And it is PLA, so what I actually did was I used a soldering iron and I just effectively welded it back together again with a soldering iron. What I should have done, taking my own advice earlier on, is don't print things in one piece, is I should have chopped the bottom off and then printed a separate bottom and screwed that on, and that would have probably been better.
The other thing you can do is get these little 3D printing pens.
Yes.
Use those to extrude filament and use that to glue them together.
That's very true, you can. I don't have one of those.
I didn't have one, but I lost it.
So what he was explaining there is you can get a device which looks like a Dremel, I guess, a little bit smaller than a Dremel, and you still feed filament into that Dremel. It heats it up, and you can use it almost to extrude in the filament and fill the gaps in and glue it back together again.
If people use them for actually manually producing things, you can actually, like a craft thing, you can actually use the filament to produce different shapes. You can put a cloth down and actually draw on the cloth, and it actually
Sticks to the cloth.
and silly things like that.
And then we've got annealing. Well, not really. Certain filaments allow you to heat treat them, which means that they don't degrade as easily once they've been treated. I don't think you can use it for all materials, but you put them in the oven, bring them up to temperature, and then slowly bring them back down again. And I think that just takes the kick out of it.
It can make PLA a bit less brittle as well if you do the annealing process.
Okay. And then the other thing that's important is, whilst you might be able to 3D print a thread, it's not going to be very strong. So one thing I would suggest is you get these threaded inserts. They go in extremely easily. Just use your soldering iron, and it really is that quick. And I've got a ton of them in this particular box here, and holding all kinds of PCBs and things in there. Yeah, you can probably get away with threading a bolt in there once, but over time it's going to rip out. There's not really much strength in there. So if you can, always use threaded inserts. Safety. Well, that's a critical thing, because you don't want something like that. Yeah, luckily that's not my finger. I did find that online, but I have been burnt through forgetting that something is still hot, or testing whether it's still hot without remembering to lick my finger. But yeah, there are lots of very hot parts on a 3D printing machine. The hot end can be between 100 and 300 degrees on some printers. The heated bed, between 50 and 100 degrees. I mean, they're extreme temperatures, but you know, they get pretty hot. The other thing you need to be concerned about is pinching. These machines are dumb. There is no intelligence in the majority of the machines that you would have on the market. There is no feedback. If you trap your finger because you've put your finger there and you've told the one of the axes to move, it will keep going because it doesn't know. Actually, the Prusa machine does have detection on there for unexpected current draw on the motors. So if something like that happens, it will actually stop. But yeah, you don't want bits of your body being pinched. You don't want to be touching exposed areas on the printer and getting electrocuted. So if you can, make sure you cover any bits up, especially if there's kids running around. And I said about scrapers and blades. Well, I've seen people with sharpened painter's scrapers and they're getting their parts off or they're pulling it towards them, and there's been terrible injuries from people holding the bed on one side to stop the the part comes off but you lose a finger or something like that. It's not good. And also a lot of these cheap Chinese printers have had all of the thermal runaway protection disabled in the firmware. Although they're using typically an open source firmware called Marlin, each manufacturer will tweak it slightly, and there have been cases where the protection has been disabled, something's gone wrong with the thermistor and it's just got hotter and hotter and hotter, and then a fire has occurred. Or you've got a cheap power supply in there and that was under spec and that's caught fire. So, as I said, do as I say, not as I do. I do leave my printer on overnight, but maybe put a smoke detector in the room where you are.
I had a problem with the thermistor on one of mine, just a loose connection, just a bolt wasn't done up properly.
Yeah.
And it didn't go into thermal runaway, but the printer thought it was and it shut itself down. So, please keep in mind that they're okay.
Yeah. So it's easy to check whether your printer has got it or not. And it can also be the other way, is it cooling down fast enough?
Yeah.
So you just disable the sensors and see what happens if your machine misbehaves, so you know you need to recompile the firmware and reflash your machine. And because it's all open source, it's easy to do that.
Sorry, on with the thermal runaway, does that mean on the print head?
Yes.
Yeah.
Yeah. So just keep getting hotter and hotter and hotter and
Most of
hotter.
them, when it gets to 300 Celsius, it just shuts the machine down.
What about changes in ambient temperature when you're printing?
That's a very, very good question. Yeah, you want to keep it as static as possible. So coming in and out of doors is not a good thing, but one thing that you can do is stick a box over the top of it, just to keep the heat in and stop drafts and things, unexpected drafts coming. So yes, you can get big acrylic enclosures that people will sell you, but if you've got a big cardboard box that fits over the top, just stick a box on it and that should keep the heat in and stop the drafts.
The other thing that throws some people is don't have it too close to the window, because if the sun comes in, that can alter the temperature as well.
That's a good point, yeah.
It's quite critical, isn't it? We did on the early machines, you know, within a few degrees C it made a difference.
And that's still the case actually, because all of the filaments have their own tolerances on what temperatures they want to print at. So when you get a new filament, it's always good to run some tests just to work out the correct temperature. And just because you tell your printer it's 200 degrees, it's a cheap head, doesn't mean it's going to be 200 degrees. It's not calibrated or anything like that really.
Tend to bring the heat tower with a new filament just so I can see which one's...
Exactly, yeah. So then there's optoprint. What's that? So there's two ways typically of printing. You could create something on your SD card and move it from one side of the room to the other, plug it in, hit print. Benefit of that is you can then shut your computer down and leave and it'll carry on printing. Great. The other thing is people will tether their machines to their computer and let the computer send all of the commands to the 3D printer. The downside with that is if you have a Windows update halfway through or something else, your print might stop and then you're in trouble. So yeah, I've never been a tetherer because I expect that to happen. So SD card is the only thing. Is the only way for me. I'm not using Octoprint, but I thought I'd share some information about it with you. It's an open source project that typically people would run on something small like a Raspberry Pi. It has a web interface. If you have one of those Prusa printers that I've been trying to advise you to buy, the PCB that actually drives the printer has all of the headers on the board to actually drop in a Raspberry Pi, what's the small one? Zero, Raspberry Pi Zero, straight onto the board, so there's no cables or anything. Really quite nice. The benefit of that is you can send it prints over the network. It will remember all of your prints, so if you just want to print the same thing multiple times, you can do that. But the really cool thing is, if you've got a webcam plugged into it, you could be up in bed. Just fire it up on your tablet and you can just check on the print. Because what I do at the moment is I get out of bed and I run downstairs and disturb the dog and check that everything's still okay, and then go back to bed again. It's quite nice, shows you all the stats about the printer, so the temperatures of the hot end and the bed and all that kind of stuff are all being fed back here. So you get all the stats you could ever want on that particular thing. In fact, the other thing that you could do with it, if you set it up correctly, is do your print and then actually tell the machine to not only shut itself down, but actually shut the 3D printer down as well, so it isolates itself, which is quite nice. So the other thing you can do with it, because it's a machine that's sat there doing nothing, is one of the new crazes at the moment is something called Octolapse. It allows you to take time lapse of your 3D print.
It actually moves the head out of the way to take a picture.
Exactly, yeah. So what's happening now is people are creating 3D models that look cool to print. They don't want them, but they just want it to look good in their video that they're uploading to YouTube.
It's called art.
So that's quite nice. So you've got your printer, but as with everything, you need to look after it. So make sure your bed's level, make sure your Z-axis is parallel. What do I mean by that? Well, you've got lead screws at each end, you've got stepper motors here. It's possible that your gantry could become tilted, especially if you just knock it because it's on a table. It only has to move a little bit and then it's not it's out of calibration. So
Well, you've had trouble getting the filament into the extruder, and you press down it. And then
well, that's another example. If you're changing filament, you're going to get some kind of movement. So it's always good to periodically just check that everything is perfectly parallel. Not level, don't get a spirit level on it, because that's not what we want. We just want perfectly parallel to each other, and then you'll level the bed independently. So just because you've got a level table and a level gantry doesn't mean your prints are going to come out perfect. And the other thing is just make sure everything is lubricated using the right kind of lubricants. Don't start using oils on the bars and things like that, because dust is floating around, and the last thing that you want is for dust to start sticking in places that you don't want them being stuck to. Just make sure you keep everything as clean as possible. And also these things are just screwed together, so with movement things will become loose. If they become loose, tolerances change, so just make sure everything is checked for tightness. Just give it an MOT every so often.
0.1 millimetre could be the difference between a good print and a bad print.
Exactly, it's tiny tolerances. So what the spools look like? Well, they look like this. The key thing that some people miss is the fact that there is a cable management, there is a filament management section at the top of the spool here. If you don't use it, can you imagine all of that spinning around very quickly, wrong way, untangling itself and then having to rewind it back on very carefully? The last thing you want is for this to get knotted in any way, because if there's any kind of resistance on this, that will probably ruin your print.
The end of it has to be stuck under one other piece when you've had it.
Yeah, so they very carefully wind. Most filament manufacturers very carefully mind this on, not all of them, so be careful. But yeah, just a little couple of holes on there, just push it through, stops it unwinding. That should be the first thing that you do when you change your filament. Do not let go of it.
Yeah. So there's three places your end of your filament should be: in
In
there,
the
in your
hot
head, or in the hot end.
Exactly. Okay, when you're not printing with a filament, keep it in a Ziploc bag. And then what I do is these little silica crystal
Most filament
things
comes
you
with a
get.
pack of silicas there anyway.
Put that into the bag, zip it up, and that will keep all the moisture out. If for any reason you forget and you find that a filament is not printing very well because it's absorbed some moisture, you can put it in the oven at a low temperature, and that will get rid of the moisture. Nylon is very, very sensitive to moisture, so you want to keep that as dry as possible. So then, what you've got to imagine is you use this filament up, and you get to the end, and you've got an empty spool, and you throw it away, and that's not so good. So I think a guy in Germany created the idea of a master spool, which is rather than buying filament with a spool on it, you print your own spool once using gash bits of filament that you've got lying around, because sometimes you get to the end of a spool and there won't be enough filament on it to do a model that you want, but you could actually just run a few filaments together and print one master spool. Doesn't matter what it looks like. And then you buy filaments like this, and they're cable tied together, and you slide it on, screw it up, and away you go. Costs less to ship around the world, weighs less, less wastage, and generally you get more filament for your money as well. So that's all good. Do we have people who make stuff here? Electronics? A few people. Anyone use Eagle to lay your PCB out? Okay, so Eagle's my tool of choice for creating PCBs. Used to be owned by a German company called CADsoft, and then Autodesk acquired them 18 months ago, 2 years, something like that maybe. They are also the same people who own Fusion 360. And what they've got a habit of is tying all of their tools together. So there's a quick little video to show you, if you were 3D printing an enclosure for your design, what the benefits of using those two free tools are.
Many of us aren't designing just PCBs or just enclosures. We're designing products. Intelligent products that integrate electrical and mechanical characteristics together. So our design and engineering workflows need to do the same. Now, the interoperability between Eagle and Fusion 360 is truly bidirectional. A mechanical designer can create the physical layout of a board in Fusion 360, and within the context of a mechanical design, they will specify details such as the mounting locations. Then the electronic designer can pull the board shape to continue the layout of the electronic components. As you could see, the physical properties of the design can be used to lay out board componentry within its space envelope, whilst maintaining all associated connections between Eagle's component libraries to an actual 3D component. This interoperability ensures mechanical and electrical teams are sharing a common foundation of data, whether that be the symbol on the schematic, the 2D footprint on the board layout, or the 3D component. The result is a PCB design that relates directly to its physical environment and shared data which is linked to the mechanical workspace where it's embedded within the hardware design. If an interference is found, as in this case in this design, changes can be made to the board's layout geometry to ensure its form, fit, and function meets the design requirements. Team members can communicate the intended design changes via red lines which are linked to the design. Changes to the layout of the electronic design will propagate to both the electronic and mechanical designers, which ensures all team members are working with the latest iteration of the design. In this case, the routes on the board are routed to account for the new board shape and the connector's new location. But it's more than just electronic design. It's more than just mechanical design. It's more than rendering, simulating, manufacturing, and collaborating. It's a comprehensive product development workflow, and Fusion 360 is the only solution with a complete PCB design workflow connected to the cloud.
Anyway, advert over. So for me, the benefit is I can design something in Eagle, I can export it as a 3D object, and I can then build the enclosure around the 3D object that I'm going to put inside it. And it is nice to be able to jump between the two applications. And the key thing is they are professional tools, but totally free to us.
Just had a question on that. The Eagle component models now, they're only 2D as far as I'm aware.
No, you can get lots of 3D stuff from them now. I can show you at the end if you,
Okay, yeah,
if you
I'm
want.
just aware of all the models I've been playing with, they're 2D for the components. So.
Yeah, sometimes you have to create
Yeah.
some yourself if you've got something unusual,
Yeah.
but a lot of them you can just either just assume it's a solid block and you can ask some dimensions of it, or it'll ask you for dimensions, or you could just inject some kind of replacement model in its place. So if it's an 8-pin dip or something, then any 8-pin dip is perfectly acceptable, even if it's not exactly the part
I
that
think
you
that's like connectors and things like that. So they're like got a 3D component, which is important when you're building.
Yeah, so I'll show you because it's changing all the time.
Okay.
Okay, and then hang printer. This is just a bit of fun, just for us to finish. Sometimes you can't build a printer big enough. So if you get a couple of parts, you put them together with a couple of lines of fishing line, string them together in your house, and you can print very large things without any frames whatsoever. Yeah, absolutely it would. But yeah, no frame on that whatsoever. So interesting movement working on that. There's a whole video there which we won't go into because I don't think we've got time. But that's the end. So if you've got any questions, then
with the this 3D printing, isn't a big part of it is that people can get designs off the internet and materials and get the designs?
I think for people starting out, it's probably the best place. So I didn't know much about CAD at all when I started. I still don't know much about it, but I know enough to be able to get me to the place I want, because there's enough video tutorials on YouTube to be able to teach you various tips and tricks.
So apart from the French houses that they're making, what's the most advanced thing that somebody can make with a 3D printer, and the type of printer that you can get, and how much are those printers?
You mean how big?
Yeah, well,
5 years ago, Brentford Institute of Technology was printing 7-ton concrete blocks 5 years ago. And they were using it for building interesting architectural features. I have no idea where they've got to now. That was 5 years ago.
Two other quick examples of where 3D printing is being used. International Space Station.
Yeah.
They print out tools. They wanted a ratchet spanner to actually do things. They couldn't make one that switched. So they did a left-handed and right-handed version. So they've got one for doing it, one for undoing. And they've actually got a filament recycler on board, so they can put them back in, recycle the filament, and print something else with it as well.
The other thing is plastic tools for servicing MRI machines.
So you can also 3D print a matrix in the medical field where they put on stem cells. The matrix will make the stem cells become a liver or a lung or whatever as well. So they print the architecture they want.
Yeah.
Stem cells on the stem cells will then go, oh, I know what this is supposed to be. Yes.
People are 3D printing clothes, all kinds of flexible materials. People are 3D printing remote control cars, including the tyres that go on them, because you can get flexible materials. Another interesting challenge that people like to do, this wasn't one of them, but I printed this just to see. This is a little iris that opens and closes just for putting screws and things on dismantling. That was printed from a few different pieces. But what people are trying to do now is to print things like gearboxes in a single print. So it's all together, and then you basically break it loose, and then you have a working gearbox on a single print that you don't have to assemble, which is quite clever. Especially if you're using something that maybe you could dissolve, like the PVA supports. You could do some very interesting things with that at home, rather than having to have expensive very accurate 3D printers.
I've printed with polypropylene before as well, which is what they basically make ropes out of. But that's a flexible filament.
How did that come out? Was that
Not
good?
bad actually, yeah. The printers I've got now won't do it because the entrance between the feed point and where it goes in the valve tube, it all kicks up. And the previous one I had was a bit more of a direct drive, and that worked quite well.
In fact, you've just raised a good point here. There's two other types of drive on a 3D printer, and you have to pick your 3D printer generally for the type of material that you want to print. So the printers I was showing you today were direct drive printers. So basically, you saw the extruder, you have the filament, and it's basically being forced directly into the hot end. Some printers are called a Bowden system, and they use some PTFE tubing like this, which allows you to put the extruder away from the print head, and then basically the filament runs inside the PTFE tube like that and guides it all the way to the head. The downside of that is certain materials are not suitable for pushing through Bowden tube like that. So that's why sometimes you have more than one printer set up for the different types of materials that you want.
The other type of filament you haven't covered, which is a bit more of a gimmick rather than anything else, is thermal change. They actually do a PLA that changes colour at 30 Celsius.
Okay. I've never heard of
You
that.
heat it up and it goes a different colour.
And then stays that colour, or
When it cools back
oh, so, okay, so it's
Which is 30 Celsius, so it's above red. I've got some blue to white, yellow to green, and I think purple to pink.
okay. I've never heard of that filament.
I heard that at the top end they'd use titanium metal to print aerospace parts with holes in them.
So my dad's company, when he worked for them, they were a hydraulic pump design company, and they used 3D printing an awful lot to be able to create prototypes and things like that, to print things. They weren't, I don't think they were printing in titanium, but they were certainly printing in things that they could then test before it then went into mass production.
There is people who have actually produced a 3D printer that is effectively a TIG welding head, and it actually 3D prints with a TIG welding head.
Mm-hmm.
It uses metal that way.
And you can also reinforce with carbon fibre as well, which is quite nice. Yes, sir.
People might like to know that, I mean, if you don't want the hassle of the costly machine and all the setup and stuff, there's a company in London that we've been using for a long time that will do SLS in nylon, 11p per cubic centimetre, which is for, you know, if you do quite a bit of that before you get to 700 quid.
Yeah. Nice. Or see this guy who might be, who might print it in for you.
So quite often as radioamateurs we want to print stuff which is okay to go outside, so how do you sort of UV, what are the issues with that and how do you deal with it?
So a lot of materials will break down with UV, but if we go back to our form at the beginning, I can't remember exactly all the details, but there are certain materials that perform far better with UV protection.
Maybe it's better than PLA if I remember right.
Right, so what have we got here? Next one, isn't it? UV resistance, so it's ASA really is your main one, so I'm guessing they use that to print sunglasses or something, but you get the idea. Yeah. So you have to pick the material that's best suited for what you want to achieve.
I suppose you can paint it.
Well, that's what I'm wondering, if the paint would attack whatever you've printed, and who knows, it's like, you know, paint on cars.
Well, the other thing that I said to people is if you're going to print like a dipole centre or something cheap like this, you put it up, pot it,
yeah,
paint it, and if you get a year out of it, you print another one. It doesn't really matter.
Yeah.
Can you actually print a dipole in a metallic form? Use a metallic?
You can actually print PCBs. There is a company printing liquid metal. So yeah, you could in effect print an antenna on your PCB. Probably expensive. It's probably cheaper just to design it and send it to China to create. Yeah, or use a bit of wire. But
There is some conductive filament you can get, but it's not good enough.
no, it's so the system I'm talking about is literally just 3D printing laying out a PCB with like a thermal paint that you could then will do pick and place on the top, so you get a reasonable looking prototype PCB at the other end. But I think it'll be a bit expensive to use it for that. Another question?
Does the extrusion system suffer from the same problem that the SLS does, which is that due to sort of porosity, it's not actually, well, I was going to say watertight. They warn you with SLS in the nylon that if you made a cup,
Yeah.
if you fill it with water, it'd be fine. If you poured petrol in it, it would just go straight through as if it wasn't there.
I don't think any of these prints would hold water actually.
I've got
Because
some cups that will hold water.
have you?
Yeah. You can actually get materials that will actually hold chemicals as well. The company that I got the polypropylene flexible material from, they do a tough material that is designed that it's chemical safe.
So, the water's held essentially by surface tension. So if you have a thing that will contact the fibres with a low angle, like because they're plastic, so an organic solvent, then which wets them, then it just whoosh goes straight through. Like it makes a good micro sieve.
I've actually printed cups that will actually hold boiling water.
Yeah, water's not a problem. It's organic. It's organic things. Like as I said, you make a cup with hold water, you put petrol in it.
Yeah.
Just put
But there is a special filament you can get that will do that. It is chemical safe. I've not tried it with petrol, but there are ones that will hold certain chemicals.
All right. Any other questions?
I guess it's probably a bit of a subject for research of what these materials do as you go from about a gig to maybe 10 gigs. Because then you can start printing your antennas, maybe. I don't know.
Right. Right, sorry. It's clear to me that if I either got to uninstall eBay from my phone or stop drinking beer, this sort of thing is far too tempting. Was this all printed at home?
Yeah, just all printed on my cheap £100
Well,
printer.
so that's amazing. Anyway, so on behalf of the club and myself, I'd like to say a big thank you very much for a very interesting talk. Thank you very much. And I'd like to invite you to join us for some tea and biscuits afterwards and a bit of a chat. So thank you very much.